Okay, so this video is regarding normalizing process. Normalizing process is also called as air quenching. Now, what is the meaning of air quenching? The spelling is this, air quenching. Air quenching means air is, as usual, it's referred to cooling only. But like with the help of air, we are cooling. Quenching as in fast cooling. So when I say air quenching, that means I am cooling the specimen at a very faster rate. Okay, so that is why it's called as air quenching. Now that is the main difference between annealing and normalizing. Okay, the process of normalizing is almost similar to the main annealing process treatment only. Just that there was involvement of slow air cooling. Here it is fast air cooling. Okay, so as you can see the graph here, we will be heating the specimen, especially the steel specimen, lightly above the critical temperature, that is around 727 degrees Celsius, such that the specimen is completely austenite. We are holding it there such that uniformly there is transformation of austenite phase, and then we will be allowing it to cool. Now that cooling process is done at a very fast rate. Okay, so there is sudden cooling of the process. Now, when it is allowed to cool, it is observed that austenite upon fast cooling results in alpha ferrite and pearlite in case of hypoeutectoid steels, and in case of hypereutectoid steels, it's only pearlite. If you remember, the same sort of formula, the same sort of reaction was discussed in annealing process. There it was pearlite and cementite also, because slow cooling was involved. Here it is fast cooling. Okay, so main reason of this normalizing process is to improve the machinability of the specimen, and also to relatively obtain a good ductility compared to the annealing process. Okay, process is the same. Even if you remember the annealing process, it was the same thing. You are heating it, holding it there for certain time so that it becomes completely austenite, and then you cool it. There we cooled slowly. Here we cool the specimen at a very faster rate. That is the main difference. Okay, so that is all about normalizing. And again, the applications, advantages, it is in the slides. Please go through them. And this is regarding the differences between normalizing and annealing. So the main thing which you need to know is that it is the cooling rate is quite faster. Here it is relatively slow. The ductility is improved much better compared to annealing, and the grain size, it's much finer in normalizing compared to annealing, and normalized specimens are usually much softer and very easily machinable again compared to annealing. Okay, so these are the main points that you should know, the main difference between normalizing and annealing. Okay, so in the next video I'll be discussing on hardening, or also called as quench hardening process. Okay.